This is a problem from section 4.3 in your lab assignment. It says, suppose that the derivative of the function is given by this. On what intervals is f increasing? So let's take a look at how we're going to solve for this problem. So this is already the derivative, and so whenever these things are equal to 0, we're looking at the maximums, possible maximums or minimums. They're essentially the critical points. For any value of x not equal to 3, not equal to -3, the even power here is going to be positive. It's only not positive when x is equal to -3, and that's equal to 0. So we know that we have positive values for that factor. For an even power here, another even power, we have another set of positive numbers. So as long as x is not equal to positive 6, we have positive values. Therefore, the sign of the product here is that these factors are always going to be positive, and then we're only going to depend on this thing when this is going to be positive or negative. So if x is equal to -5, this would be, or when x is less than 5, this would be a number less than 5, like 0 or 2 or 3, and then that would make this a negative factor. So this would be a negative factor, and so the sign of this whole thing would be negative, and therefore it would be decreasing. So if x is less than -5, we have the function is decreasing. And so when x is bigger than 5, then this factor here, this x would be bigger than 5, so a number bigger than 5 minus 5 is going to be positive, and to the third power is going to be positive. Therefore, the whole thing is positive, and it's going to be increasing. So f is going to be increasing on the interval from, I guess it just go from 5, and it will go all the way up to infinity. And there it is. So we don't know what the original function is because we don't, all we're given was a derivative, and we're given the derivative in factored form, and so we're able to figure out at least where the function is increasing and decreasing.